Okay, this is an edit of the panel meter calibration. Yesterday when we filmed this, it was apparent that there was some parallax in there. So we recalibrated this meter with a better set of eyeglasses. And let's go ahead and test it, and we'll walk through some of the points. And they should be, if you look at it straight on, they should be pretty close to the actual calibration points. Let me just skip ahead to a few, and we'll pick a few at random. 12.5, 13, 13.5, 14. Scale gets very compressed up at around 20, so 19, 19 and a half, 20. So that looks pretty good. And now for the SWR. We'll pick a couple of points at random. 2, 2.1. Here, where there are no discrete tick marks, you have to kind of use, again, you have to eyeball it, but it's not too difficult. You can always go back and 4.8, 4.9, 5. So that looks pretty good. So now when we try to do some real measurements, we expect the meter to line up with the digital values. Okay, now we'll run through some real power tests. Just want to show you what I have set up. This is set for instantaneous power. This is set for instantaneous power. The other thing I wanted to point out, we're in the auto range mode. We're going to be able to switch from 20 watts, 200 watts, 2000 watts as we overrange. I have this set to instantaneous power, and I have this set to the full scale value. So for example, if I start down at a low power and exceed 20, you saw the overrange, I'm in 200. If I kick the amplifier on, I'm in the 2000 watt range. So keep that in mind in terms of doing an evaluation of what the meter is actually reading. We'll just be using the top scale. Again, this is going to be 0 to 20, 0 to 200, 0 to 2000. And we'll pick a couple of numbers at random, and the bottom line is that this number and this number should agree. So I'm in the low range now, 0.33 watts. This is my 0.5 watt indication. And not sure if I mentioned this. This is a nonlinear, highly nonlinear segment of the meter, because Meter Builder does a linear interpolation between each of the samples. When you look at this, you can do a linear interpolation as well. And 0.33 is not too bad of an estimate. It's the RF output control is kind of touchy. At the low end, 0.64, 4.57, so that's 4.5, a little bit beyond that. 6.57, looks pretty good. What am I at now? 13.64, reasonably good. The number that will be hardest to achieve is if you look between 19 and 20, there's very little space. So it'll be interesting to see if we can accurately dial to, let me get back into the lower range. Okay, 19.31, I'm in between. 19.94, I'm pretty close to 20, so the most challenging range between 19 and 20, looks like we've done a pretty good job. Now when I exceed 20 watts, I upscale to the next range, which is the 200 watt scale. So I'm now reading 0 to 200 watts. Let me go ahead and bring it down close to the bottom end of that scale, 21 watts. So again, that's 10 watts, 20 watts, 30 watts. That looks pretty good. 33 watts looks pretty good. Let's try to get right on 50 if we can. Pretty good. 100 watts, 110, 140, about 155 or 156, and the max this guy will get up to is 192 watts. And let me see if I can zoom in on that a little bit. All right, that looks pretty good. Last, we'll go into the higher range. We're now in the 2000 watt full scale, so again the top range is 0 to 2000 watts. 432 watts. We try to get toward the bottom end. 224 watts. Let me try to line up on 300. Pretty close. Let me try to line up on 500. Pretty close. Let me pick a number at random. 742. Looks pretty good. 982. Let me see if I can get right at 1,000. Well, that's close enough for me. So the calibration did a pretty good job of power. Now we're going to check the SWR calibration with real power conditions. Okay, now we're going to test the SWR, and let me just show you what I have set up in terms of settings. This is instantaneous power. This is the SWR. We never showed min-max with a real live power condition, so we can kill two birds with one stone. This is set up to show the real-time SWR. So let's go ahead and key the transmitter. I'm driving into a reactive load that'll give me an SWR anywhere from 1.5 roughly up to 10. So right now I'm starting out at 2. Let me go ahead and use the min-max function because I wanted to again demonstrate that. Okay, my SWR of course at this point is the same for both. As I go to the part of the band where the SWR is lower, looks like I get down to 1.55 on both meters, both the digital display. You can see that that's what the min SWR captured. And now once I go above 2.3, I'm at 2.87. I'm more or less consistent with the digital display and analog display. Go to an easy number, 3.5. We try to get to 3.75, pretty close. 4, 4.5, 4.75 looks pretty good. 5. Now you recall we calibrated this meter for a maximum SWR of 5. So while you'll see the digital display continue to go up all the way to an SWR of 10, and you'll see that higher SWR being captured with the min-max function. You recall as soft overrange works, soft overrange will limit me to whatever excursion I defined during panel meter setup. So it's only going to allow me, I believe we set it to 10%, to go roughly 10% above the drive, current drive that corresponds to the full scale value of 5. So the bottom line is that the calibration, without the parallax problem that I had the other day, looks pretty good. So this meter is set up for real-time power. for actually any type of power. Maybe we'll key in some CW and show how it looks with a keyed CW signal. So let me set that up, and we'll be back in a second. Okay, now I have the meter running with pre-programmed message from an MFJ keyer, and you can see, we believe that MB1 is the only digital meter that has a real-time analog display. I'm going to crank up the speed of the MFJ keyer to its highest setting. Okay, and it does a pretty good job of keeping up with it. Let's pick some of the other power modes. Okay, you can see the averaging filter kick in. Peak. I've got this set to peak, so the peak value here and the peak value here should more or less coincide. Probably you're not seeing the peak drop off much because of the speed. Let me slow it down a little bit. Okay, I've got an 800 millisecond peak hold. What else can we display here? Reflected power is basically 0. Let me kick in something that has a reactive load. Okay, so now I'm seeing the real-time reflected. I'll turn off the reactive load. That's real-time delivered, and again, if I kick in a reactive load, you can see the value change. If I went to constant carrier, you'd see it a little bit more, and the difference is only 11 watts. So that's why we're not seeing much of a difference with the keyed CW. Okay, SWR. Interestingly, the SWR does a pretty good job even in the presence of time-varying signals. Min SWR and max SWR we'll save for another topic. While we have this running, I can go ahead, okay, and show you the Dewa meter that we calibrated the other day. Crank up the power a bit. And again, it too can go through the different modes. Average, peak. Peak is pretty close to 197 watts, and that's what the analog meter is showing. Delivered real time, and that's basically it. The only thing we didn't show was the internal cross needle meter. Okay, and again, I'm driving into a reactive load. If I switch in a resistive load, if I switch in a reactive load, you can see that both the forward and reflected needles follow the speed of the signal pretty well. So for those of us who got used to looking at the bounce of the analog meter back in the 70s and 80s and maybe 60s, that's comforting to have. And so that's the story on verifying the calibration of the analog meter.